Hello everyone, my name is Abdulaziz Abu Ahmed. I'm an electrical engineering student. Today I will talk about railways and electrical engineering student and the relationship between them. So, starting with the introduction, we can say that the development of railways and electrical engineering are closely related, as the growth of railways played a significant role in advancing electrical technology. So, railways needed efficient and reliable ways to power their trains, which lead to the development of electrical systems of locomotives and signaling. So, in turn of spurred of the development of electrical power generation, transmission, and distribution systems, the growth of the railways industry also created a demand for electrical equipment, such as transformers and switches, which further drove advancement in electrical engineering. The two industries have continued to influence each other, with the development in electrical engineering helping to improve rail transportation and vice versa. Moving to the direct current motors (DC) and alternating current motors, which is AC. These types are two types of electric motors that are used for different applications. So, starting with the direct current motors, which is a type of motor that runs on direct current (DC) electricity, which is under the directional flow of electric charge. So DC motors are commonly used in applications that require precious control, such as in toys, drill, and servo motors. They can also be found in electric vehicles and some industrial application. Moving to the AC circuit motors, which is the type of motor that runs on alternating current (AC electricity), which is an electric current that changes direction periodically. AC motors are commonly used in household appliances, such as AC fans and refrigerators, as well as in industrial applications such as pumps and compressors. They are known for their efficiency and low cost compared with the DC motors. Moving on, the rotational speed of a DC motors that can be controlled by adjusting the voltage applied to it, while the rotational speed of an AC motors is determined by the frequency of the AC power supply, of the AC power supply. So for the DC motor, the rotational speed is proportional to the supply voltage and inversely proportional to the motor's back to electromotive force, which is EMF, which is constant. So the speed of the DC motor can be regulated by varying the voltage applied to it or by adding an external controller. For the AC motors, the rotational speed is proportional to the frequency of the AC power supply and the number of poles in the motor. The speed of the AC of an AC motor cannot be easily adjusted, and separate speed control mechanisms must be used if the speed needs to be adjusted. Moving on to the vector control in the circuit motors. So vector control is a method of controlling the speed and torque of an AC electric motor by adjusting the magnitude and the frequency of the voltage applied to the motor. It's also known as oriented control (FOC). Vector control involves determining the orientation of the magnetic field produced by the motor and controlling it in real time. By controlling the magnetic field, the vector control system can precisely regulate the speed, torque, and power of the motor. So this allows for high precision control of the motor, making vector control useful for applications where high accuracy is required, such as in CNC machines, robots, and other control systems. Vector control is considered more advanced method of motor control compared with to the traditional scalar control methods, which is simply adjust the voltage magnitude applied to the motor. So vector control provides better performance, improved efficiency, and greater accuracy in controlling the motor's operations. Moving on to the brushes in the DC motors. So DC motors have brushes, while the most of AC motors do not have. Brushes is in a DC motors transfer electrical energy to rotating armature and make contact with the commutator to change the direction of the current flowing in the armature, which allowing the motor to generate rotational force. EC motors, particularly the induction motor, generate rotational force through electromagnetic induction and do not have a commutator or brushes. However, there are some specialized types of AC motors that have brushes. Brushless AC motors are becoming are becoming more popular due to their high efficiency and reduced maintenance and reduced maintenance requirements compared with the brushed DC motors. Moving to the first railway vehicle powered by electricity. So in 1879, Siemens exhibited a railway vehicle powered by electricity for the first time. This marked a major milestone in the history of rail transportation, as it marked the transition from steam powered trains to electric trains. The railway vehicle was powered by an electric motor, which was supplied with energy from an overhead power line. This new form of propulsion provided many advantages over the steam power, including smoother, quicker, and more efficient operation, reduced pollution and fire risk, and the ability to run longer trains. So the success of this demonstration lead to widespread adoption of electric traction in rail transportation, and Siemens become a leading supplier of electric locomotives and electric equipment.